Good morning, everyone. And I would like to start to telling in March 1973, an edition of Scientific American magazine was published. And that time, this magazine make an analysis to understand who is the most efficient animal on the planet in locomotion way. So in this study, the researchers found that bird, like a condor, a type of bird, is the most efficient animal on the planet in locomotion. And us, the human beings, are also evaluating this study. And we became in one of the last position of this ranking. So the researchers have the idea to evaluate us using a bicycle. And when they did that, we went from one of the last position on the ranking and took the first one, far ahead of the condor. So based on this study, that Steve Jobs says something in one of his talk, and I would like to share with you today, because this is the first reflection for the day. That is, human beings are two builders. So us, human beings, are two builders. And it means that you can build tools that enhance our capabilities. Like we can, using a bicycle to enhance our locomotion. You can build glasses or binoculars to enhance our vision. And you can build generative artificial intelligence to enhance our productive and our mental capacity. So it's about that we are talking today. I'm Vinicius Carida, and a pleasure to be here in a reInvent speaking about the generative AI. The reInvent is the biggest technology event in the world, so it's a very honor to be here with you today. And yeah, please, if you can add me on the social media, and any post that you make today about this talk, please tag me, and it would be great to have in contact with you. So I'm working in a bank in Brazil, the largest bank in the South Hemisphere, the Itaú Bank, and I am also a professor there, and I love to be engaged with the technical community, and because that I'm here today as AWS Machine Learning Hero to talk a little bit about this technology and how this technology can help us to build something that can bring value for the society and bring value for the business and etc. So let's go on. And to start, I would like to do some analogy with the car evolution. So the car arrives for the society in 1860 and 87, and when the cars arrive to the streets, the society have a lot of fear about this new technology. So this technology could cause accidents, could kill people, and etc. So in that time, in that time, there is a lot of fear about this new technology, uncertainty and distrust about it. And a lot of newspapers publish some accident photos, and even some reports compare horses with the car. So maybe automobile is better than horses. I don't know. Maybe you can change your horses for one car. This technology that we don't know about it. So because this fear, even a law was created in that time. And in 1978, one law was created. The name is the law. It was Red Flag Law. And the law said that if you bought a car, you need to hire a people to walk in front of your car using a red flag to signal the arrival of the car. And in the night, this person needs to bring a lamp to signal this car. So this is what happened in 100 years ago. But of course, the automobile industry involved, the researchers continues, the evolution continued. And one very important milestone in that time was when the Volvo invented the three-seat belt, the three-point seat belt. This three-point seat belt is the seat belt that we already use today. and it's a very important safety equipment for the cars. And an important fact is that Volvo left the patent open in that time. So if you bring this, this concept for artificial intelligence world or development world, you can think about the open source things. I'm very fond of the open source, so this, when the Volvo invented this three-seat belt, the company thought that's very important to open this new technology because this technology can save lives. This technology will be better for the society. And even the competitor using this technology will be great for all automobile industry. So they left it open and help to all the automobile industry to evolve, and that today we have the cars is a very important tools for us, correctly? So beside the three-seat belts, the three-point seat belts, we as a society need to do some evolution, for example, in some laws, we even building new safety equipment like ABS brakes. And for example, ABS brakes also invented in 1984, 100 years before the cars. So the new technologies need to be discovered every time to have a very good solution for the society and for the business. So here I would like to share the second reflection for today. Is a quote for Einstein, and it said that it at first the idea is not absurd, then there is no hope for it. So if at first the idea is not absurd, so there is no hope for it. And in other words, it means that every new technology arrives with uncertainty, arrives with some fear, and you need to understand how the things works to put efforts there, involve there, and bring real benefits for the society, for the business, and etc. And this is the same with artificial intelligence, or generative artificial intelligence. I think the last year, this technology arrived massively in the people's hands, but it has been researched for more than 30 years. For example, here I have a thesis, a doctoral thesis at Harvard that defended us 1990, so 30 years ago, and the researchers built some algorithms to generate text to describe images. So 30 years ago, you have some applications about it, but only the last year, this technology became a product that arrives in the people's hand. And when you look for the Gartner hype cycle, the last year, the generative AI already left the trigger of innovation phase, and it starts to be in the inflation point. And this year, 2023, the generative AI achieved the maximum point of the inflation. So probably now, this technology begins to enter in this disillusion phase. So, but it's not a bad thing. It's a good thing, because now we start to understand better and deeper what is generative AI, and start to understand that generative AI can't solve anything. It's a tool that can solve some business problems, some society problems, and you need to understand that and put efforts to use in the better way. Okay? So, how is the whole potential of the artificial intelligence? I think I have sound here? No? Okay. Have some music in the background, but okay. This video try to make an illusion about robot here, or the robot here is making the illusion of artificial intelligence. And here, the robot can perform many tasks better than us, than the human being. But another tasks, we being nature, human nature. So human will be performance better than artificial intelligence, but you can use artificial intelligence as a tool to help us. For example, you can use a hammer. It's a tool that can allow us to do better some jobs, and etc. And here, I would like to share with you a matrix proposed by the researcher Kai-Fu Lee. In this matrix, you have two axes. In a horizontal axis, you have in one end activities or tasks that demand creativity or strategy. In another end, that activities that could be optimized. And the vertical axis, you have in one end tasks that they need compassion, and another end that the tasks that don't need. So all the tasks or all the activities in this quadrant that these tasks could be optimized 100% or repetitive tasks and don't need the compassion, the AI will dominate these activities, okay? But some activities that don't need, the activities that could be optimized but need some compassion, need some empathy, the AI will be in the center doing the analysis, but us, the human beings, will be using this analysis oh, it's alive here, sorry. And this kind of activity have the human bring the harm for this text to help the customer or help some people and etc. And the third quadrant here are activities that need the creativity and the strategy, but don't need the compassion. Like, for example, I'd like to write a book or a social media post. I can use AI as a tool to write the first draft or something like that. And then I use my creativity to rebuild it and finish this job. So AI as a tool and us using this tool to help us to do better these tasks. And the first one is the activities that need the creativity and the strategy, and the compassion and empathy is needed. So this is the activities that we are, as human beings, will dominate it. But even that, it's very important to use AI as a tool to help us. It's okay. And that's not me talking about it. We have several specialized researchers that try to understand the impact of this technology in the world. For example, McKinsey do some globally researchers to understand the impact of this technology in several use cases like marketing, sales, software development, and etc. And yeah, when the generative AI could bring more productive and mental capacity for the people can use it. Another very interesting study was by Boston Consulting Group. They made an internal experiment with consultants, with some consultants use generative AI, and another group of consultants don't use. And the group that used generative AI could finish a lot of more tasks faster and with better quality. So it's an internal study of the BCG. And you have a dozen sources about it, like ISM, Forbes, International Labor, Bloomberg, and etc. And here, we have a video that also have a music in the background, but it's okay. And this video, we see Photoshop. It's a very famous tool, integrate now with generative AI. So, of course, you continuously need to people that know about arts, visual arts, image editing, and etc. But before, the people spend a lot of time to do some editions here. Oh, sorry. Okay. Oh my God. It's plus. And the people spend a lot of time to do some image edition. Okay, it's going, I don't know what happened. Let's stop here. Okay. Oh my God. It's alive. It's past. Okay. I need AI to help me here. So, come back for the thinking here. So using this tool, like Photoshop, integrate with generative AI, even don't have deep knowledge about this tool, you can do some editing images very faster than before. So generative AI can help us to do the tasks more quickly and more efficient. But you need to understand a little bit how it's work. It's very important to understand, because come back to the study about the locomotion. Thinking about a competition with have some people in foot and some people using a bicycle or even a car. It's not fair, okay? Because the people using a bicycle or a car, we born more faster than people on foot. And even if you give a bike for someone that cannot ride this bike, it's even worse because the person needs to carry on this bike and it's not good. So it's important to understand how to use this technology to embrace our capabilities. So here's the 30 message that I would like to share with you today. You won't be replaced by AI, but you could be by someone who knows how to use AI. Again, relax. You won't be replaced by AI. It's the very common question. But you could be by someone who knows how to use AI to embrace our capabilities. And let's to understand a little bit more how AI works. And in a general application, we have some user input. This input go through the artificial generative AI application, and this generate output for the users. And for example, if I ask for an application, I would like a text about generative AI, so the system will put some text like generative AI, it's a breakthrough technology for us, and etc., and etc. So this is a general application in an LLM applications using generative AI. For example, if I would like to use more specialized services like Amazon Code Whisper, in this application, the user input is a text to ask about some code, like parse a CSV to reshape a string and etc. And the output of the system will be a code that solves this demand. Okay? And so it's important to understand and open a little bit more this generative AI application toolbox and understand some main stage that you have behind this application. And you have 4 main stages behind the generative AI applications. The first one is understanding, then reasoning and knowledge, generation, and safety and responsibility. This is the 4 main stages behind the generative AI applications. And the first thing that I need to do is understand what the input means. Because the user will give us an input with some demands, and you need to understand what this input means. And then you need to understand if it's possible to improve this input. And now we start to talk about some prompt engineer here, because prompt is very important to enrich this input and maybe achieve better results. Then you need to go for the second big stage, is reasoning and knowledge, and we start to understand how to solve this demand. That once I understand the input, I need to know how to solve. And here we start to talk about some frameworks like chain of thoughts, RAG, and etc., that allow us to build a reasoning to solve some problems. And once I know how to solve, I need to know where is the answer. What data have the answer that I need to provide for the users? What is the content, and etc. So here we start to think about the retrieval information or other components to help us to find where is the answer is. And of course, when I have the data, when I have the information, I will start to generate the answer, and sometimes I need to customize this answer for a domain, for a customer, or etc. And at least you need to do it in a safety way. Generative AI is a very powerful tool, but like Ben said, with great powers become with great responsibilities. So you need to do it in a safety way. So this is a good solution here. It's safety, it's responsible, and then we finish this life cycle. And of course, it's very important, monitoring and improvement. This is not a workflow, this is a life cycle. So all the time you need to monitor and improve all these steps every time. It's a very important thing here. And again, generative AI is not one tool that solves all the problems, okay? You need to think it's because that AWS have an entire AI ML stack to allow us to choose the better tool to solve the business problem, the society problem, and etc. And this stack are divided in 3 big layers. One is the provider, then tuner, and consumer. The provider is related from frameworks and infrastructure that you can use to training model or put the model in production. Tuner is related more in SageMaker tools that allow us to build our own model, and AI services that have some pre-built services that help us to have more time to market and put some applications in production. When you look for only the generative AI tools in this stack, we have some specialized computing to training these big models, because you need some deep powers, GPU, and etc. You have the SageMaker Jumpstart that you see in a few moments how to use it, and it allows us to use an open source model. Like I said before, open source is very important. Some companies trying to close the solution, but another ones are open the solution. For example, in Hugging Face portal, you will see that it's very easy using SageMaker Jumpstart to load a model available in Hugging Face portal, for example. And then in the consumer layer, you have some specialized AI services like Amazon Code Whisper that I already saw, that generate code for us. And in the end, in generative AI, you have the Amazon Bedrock that allows us to scaling generative AI, and Amazon Titan. That's a foundation model built from AWS. So you can choose to use this foundation model from AWS, but if you choose to use Jumpstart, you can load any model available on Hugging Faces and etc. But here is very important to think that beside these services that AWS provided for us, you need to integrate on other frameworks and other components to have an entire generative AI solutions that can bring results for the business and for the society. And I will explain a little bit about these components. That is very important. Because the first thing is about the prompt. But prompt is a technique. And there is several techniques that allow us to build a good prompt, like React, MRQL, analogical prompt, and etc. So we need to choose one of these techniques to building our text for the prompt. And when we have this text, we need to transform this text in token and then embed representation. And once you have this prompt in an embedding way, representation, you can use this prompt directly in a foundation model, for example, Titan or other models. I can use it directly. But when you talk about LLMs, it's important to know that at least we have 2 stages from pre-training and the foundation models, and one alignment from the data. And one of techniques to alignment to the data is a supervised learning that the name is RLHF. The very famous techniques for it is the reinforcement learning from human feedback. So you can use it to do the alignment with the data. But when you choose to use the prompt directly into the foundation model, we are using the knowledge for the pre-training. You are using the pre-training knowledge for this foundation model. And sometimes you need to use our own data and not the word knowledge. You need to use our own data. So in parallel, and the tuner layer here, you can see some frameworks that help us to use our own data, like HAG, agents. Agents could be an API, for example, that access the internet and brings some information or access some internal system and etc. And you can do some changes for the RAG, like RAG Fusion. You can use frameworks like LangChain, Llama Index, and depend of our own data, you need to use some chunks to put the data in a better way. And of course, if I need to use my own data, I need to store and retrieve this data. And because that, I need to use some vector database and some vector search to understand. Do you remember the main stage? I need to looking for the answer. Where is the answer? Where is the data that I need to use to generate the answer in the end? So I need to store this data in a vector database and use some vector search to retrieve this information. And then this information will enrich our prompt that using the foundation model. Another important thing is, besides you decide to use the word knowledge or your data knowledge, you can do some fine-tuning the model to customize this model for your domain. For example, financial services domain, or some languages, Portuguese or English, or etc. So you need to use more frameworks to do it in an efficient way. For example, LoRa and Kilora help us to have a very efficient parameter fine-tuning to customize the foundation model for our own domain. So it's very important here. And once we have all this application ready, we would like to put in the production, right? So for do it, you need to do in a safety way. So you need to build some guardrails. You need to build some hallucination metrics. You need to build some bias studies, and etc. And in the end, when you need to serve this model, and 7 billion parameters, 100 billion parameters, you need to put this in an efficient way to serve a lot of requests. So you can do it in for example, using another technique, it's GPTQ. It's a quantized model that helps us to put into production using, for example, some flash attention techniques, or flash attention algorithms, that allow us to have this model in production in very efficient way. Because if you use the standard attention layer in your neural networks, you can do that. So you can use some techniques for it. So in the end, in short, AWS can help us in 4 main lines how to use generative AI and put into production. But very important thing here, generative AI cannot be your data and AI strategy. Generative AI is only a tool that allows us to erase some capabilities, bring some value, but it's only a tool. So because that, you need to think and build an end-to-end data strategy. It's very important to build an end-to-end data strategy because the tool is not the most important thing here. The data is important. The business case is important. So you need to build the end-to-end strategy, starting with the data, applications, machine learning, and etc. So the first step, and every application start with define the business use case. What the problem I would like to solve here? Then the data, very important thing. I need to have the data. I need to understand the data. I need to have access to the data. Then you can go for the third, for selecting the algorithms, build some data pipeline and feature engineer, building the machine learning model, and very important step, evaluate. You need to have some metrics to evaluate hallucination, bias, and etc. If the result's not good, come back for the first step and start again. It's normally in the machine learning world, every time you need to start again, even and few hours training a model. But if the results was good, you going through to the results, to present the results for the stakeholders, plan for deployment, put the model in production, and every time monitoring and improvement, because that's it's a life cycle, it's not a workflow. So improvement and monitoring, it's constantly in this application, okay? So come back for the generative AI applications. Remember, I have a user input, some generative AI solution, and the system output. And let's go again for the generative AI boxes here. And let's try to understand another use case to understand better how it's work. So if I ask, for example, for a model, a beautiful galaxy, one application, very famous, is Stable Diffusion. This application will generate an image for me. Oh, the image that it's related for the input, a very beautiful galaxy. And to do it, I need to not only have the text representation, you need to represent the image too. And to do it, a very common way to do, it's using a convolutional neural network to understand the image. You need to transform the image in a matrix, and each pixel of the image became a number in the matrix, and you can use convolutional neural networks through the filters, and these filters, you understand the small partners from the image, and when you put together all these partners, you can understand which image is here. And when you bring this knowledge for the diffusion models, you need to take one image and add noise in this image and learn how to return for the original image. Like that, I have the dog image, I put some noise and need to understand how to back for the original image and put more noise and understand how to back and so on and so on. So when the model was trained, I will start with a very random noise and could generate a new image for about the input related for the user input here. So you can use all these techniques and algorithms like convolutional neural networks, filter, etc., to do this learning here. But also, I need to use more techniques to other steps to have the entire application working. So the second thing that I need to do is put together the text representation and the image representation in one single representation. So I can use some variation autoencoder to take these two vectors, the image and the text, and put together in a single representation in a matrix. And then use another algorithms that is UNet convolutional neural network to use as a noise predictor. So it allows us to understand what the noise is and understand what is the original image and what is the noise, and understand how to build some new images. And here you have this noise predictor architecture that mixed some techniques like ResNet, attention layers, and etc. So in the end, to training this application, we have this architecture. So this architecture is formed for some components like latent space for diffusion process, the text representation, the noise UNet steps, and then in the end, I need to have this same image. So going through step by step, it starts with an image, like a beautiful galaxy here. Then you need to add the noise in latent space from the convolutional neural network. Then add some text representation here, like a beautiful galaxy, the text that describe the image that I'm training here. Then I use it to generate an image and learn the noise. And the end, I need to have the same image for the beginner. So I'm training this architecture a lot until I have this result. Okay? And this is a lot of techniques, algorithms. You have some complexity in these algorithms too. But we can do it in a very easy and fast way using AWS SageMaker Studio Lab. Here I have an example. All this code is available in my GitHub. You can use it. And here, AWS SageMaker Studio, you can do it using only 6 lines of code and less than 10 minutes and spending no money. It's free. You cannot spend any money here. So in the first block of code, we are loading the stable diffusion model available on Hugging Face portal. It's a Brazilian fine-tuning model that we and some colleagues put in Hugging Faces, and you can use it and test and send some reviews for us, please. And you can use it for free on AWS SageMaker Studio. Then, the second block of code, we are loaded all these techniques that I already said, like variation autoencoder, UNet convolutional neural network, test encoder, scheduler, tokenizer, one line of code for each technique, each algorithm. So very easy way. You don't need to understand deeper any of these algorithms. And the last one, the last block of code, we have the prompt that you'd like to use as an input from this application. Like I ask here to generate a photo of a CTO of a technology company. And then you have some parameters for the size of the image and etc. So when you use this technology, I asked, for example, a photo of a person from the United States. And this solution generated this image here. And then I try to enrich a little bit more my prompt. So I ask for a photo of a person from the United States that work at Amazon's Web Service as a vice president and chief evangelist. And the model generated this image here. So it's the model, it's not me. So it remembers something, but it's okay. Let's move on. And what is very important here? You can use this model for free very easily in AWS SageMaker Studio Lab. But in a real world, you need to sometimes specialize this model. For example, for some business, you need to specialize for some domains and etc. If you don't need to specialize, as you can see, it's very easy to use. But sometimes the data, it's outside of the training. For this very toy example, the model knows which is a cat, the model knows which is a dog, but the model don't know what is a rabbit, because I don't have pictures about the rabbit here. Of course, this is a toy example, But for example, in a bank that I worked, we have a product that the name is multiply. If you go to understand what multiply means in a normal word, multiply is related for some mathematical equations. But for the banking, multiply, it's a name of a product that have two functions in the same time, debit and credit. So if I ask for the model about something like that, the model, you don't know about it because they don't have data to understand what is this. So I need to specialize this model. And of course, here, I would like to compromise any company. I need to be safety here, but I choose to compromise a person. He's a very famous person. It's Jeff Barr. I think everyone knows Jeff Barr. Jeff Barr is very famous from AWS. So I choose to compromise him here using some example. So if I ask for a stable diffusion, a photo of Jeff Barr, this application will generate this image here. And this is not a Jeff Barr. So I can enrich my prompt and say, please generate a photo for me of Jeff Barr. That Jeff Barr works in AWS as a vice president and chief evangelist. Even that, with this new prompt, the model generates this another image. It's not looks like Jeff Barr. It's another image, very different for the first, but don't look like Jeff Barr because the model don't know who is Jeff Barr. They don't have this data, this information. So you need to teach, you need to specialize the model to know this new concept, this new information. And of course, this is the Jeff Barr. Jeff Barr is a very famous guy from the AWS. He's a very fantastic guy. And I have the opportunity to meet him 3 times in my life, and every 2 times I asked to take a picture with him. Maybe after this talk, he not accepted to take pictures with me again. But yeah, I can use another technique to teach this model. And this technique I have a lot of techniques, so I choose detection inversion. Using a detection inversion, this is the high-level architecture for detection inversion. I can specialize the model. Using some few examples of the images and few examples from prompts to describe this image, I can specialize this model. As you can see, I have one example of the prompt is a photo of S. S is the new concept that I would like to teach the model. And on another side, I have some input sample, this kind of clock here. So I use these two data to specialize this model. As you can see, some parts of this architecture have a lock because you don't need to lost the previous knowledge from the model. We're freezing some neural networks weights and just put the new knowledge, the new concept in this model. So for example, the new word that I would like to teach for the model with some examples. So for example, I can teach the model a new yoga pose, and when the model knows what is this yoga pose is, you can generate images in this pose. I can teach the model about this straight cat and generate the model about it. So to do this specialized model, now I can move from the AWS SageMaker Studio lab to the AWS SageMaker because I need more infrastructure power now. I need to use some GPUs and etc. And I will start, again, all this code is available in my GitHub and you can use it and etc. You can use it for your family photos and etc. It's very fun. So, so the first block of code, we need to start to some parameters. I would like to teach the model who is Jeff Barr, and Jeff Barr is a person. This is the placeholder that you can teach the model. And the second block of code, I'm loading the stable diffusion model, the foundation model, again, from the Hugging Faces. So I'm taking this foundation model, and then I will specialize it. So for do it, I need to stalk Jeff Barr in the social medias. So I go for some social medias from Jeff Barr, took some pictures, and only 9 pictures. As you can see, very few examples, and with low quality, because I do some print screen, crop the image, only the face for Jeff Barr, so very few examples here, and very low quality. So I get this data and put in the model, like the architecture that we saw. Use some photos, the 9 photos from Jeff Barr, and then some prompt examples. Like, this is a photo of Jeff Barr, this is a painting, and etc. And then, in the last part of the code, you need to train this model. So, as you can see here, I just training this model for 15 epochs. It's very little time to do it, very, very little to show you that it's very possible to use with less data, less research. We using only $20 and 3 hours for training. You can have our own personalized model. So in the first block of code, I have the training, and the training said I would like to train a text encoder application, and I loaded the previous foundation model on Stable Diffusion, then the placeholder and other stuffs to do this training. And then, in the end, I can ask for the model generate something like a painting of Jeff Barr as a vice president. When I did it before, the model generates something with no sense, because they don't know who is Jeff Barr is. But now, using only 9 photos, use few data, few example, I teach the model using the textual inversion technique, textual inversion algorithms, and then let's see the results. So here's some photos, some paintings that the model generates from Jeff Barr. And yeah, you can check if it looks like Jeff Barr. So I'm very honored, a little bit nervous, to ask for Jeff Barr. Come here with me. Jeff, please. Thank you again. Thank you.
Wow, so what a crazy world we live in, that we can do these amazing kinds of things. Awesome demo. So a couple months ago, I was just going through my email, which usually takes the first 3 hours of my day, and Vinny sent me a very nice email and said, I'm getting ready to do a reInvent talk, and I have got this really, really cool demo, and he kind of walked me through it, and he said, would it be okay if I used you as the example? And I said, of course, that'd be totally awesome. That'd be super, super neat. And I didn't quite grasp the entire intent of what he was doing, and I said, you know, I've been collecting selfies for almost the last 3 years, and I had like 900 selfies. I volunteered to send them. He said, no, I can do it with just 9, and I've already got my training data, which was super, super cool. If you need 900 selfies, let me know. I'll happily share those with you. I do actually kind of think that we need to keep the universe in balance, and that if someone wants to do something a little bit cool, you kind of have to respond in kind and say, well, I'd be more than happy to help out and to do what I can to be here, and just say, wow, this is so amazing what you've done here. And I look at all of those layers that you've kind of walked us through of how do we set up the training, and how do we generate, and all those edge detection and all those matrices, and I'm thinking there's like 9 layers of things I will never ever understand, but you've packaged it up for us in this really amazing way that makes it, I think, understandable and approachable and very usable and very, very powerful. So awesome work. Really appreciate all that you've done here to make that something amazing.
Thank you. Thank you, Jeff. It's very kind to you to have you here with me. Thank you very much. And
can we do one more?
Looks like Jeff Barr did the photos, or no?
We have to do one more selfie.
Oh, let's do it.
Let's get our audience.
With the audience.
Get our audience.
Okay.
Here? Perfect. Okay. How about that? We're good? we'll get that, all that light. Let's move over right a little bit. Awesome.
Great.
All right.
Thank you.
Great
Thank you
work.
very much,
My
Jeff,
pleasure.
for being here. Thank you. And everyone, thank you again. It was a pleasure to be here talking about generative AI fuel. Here have some my QR code with some social medias links. Please add me.